In the discussion of a series of lectures on quantum mechanics, this last portion remains the hydrogen atom problem, lecture 13. And this topic, I think it will take 3 to 4 lectures. And in part 1, this is first one of this series of lectures on this hydrogen atom problem, I shall discuss the Schrödinger equation of this system. Hydrogen is the simplest of all the chemical elements. Hydrogen contains only one electron and one nucleus, and the nucleus again contains only one proton. So whenever we shall discuss the motions of this hydrogen atom, we may consider two types of motions. One is the external motion. In this case, the hydrogen atom as a whole moving from one point to another point in space, and it is a translatory motion, and this motion can be taken as the free particle in quantum mechanics. And we have already shown that for this free particle, the energy will change continuously. So quantum mechanics need not be applied for this translatory motions of this hydrogen atom. Then another motion is the internal motion, means this motion of this electron and the nucleus within the atom itself. Though electron and nucleus both are moving, both are rotating, but the nucleus is about 1836 times heavier than the electron. So whenever these two are moving with respect to one another, this nucleus remains fixed at rest, and it is called the fixed nucleus approximation, and only the electron is in motion within the hydrogen atom. The location or the position of this electron within the hydrogen atom is described either by Cartesian coordinate xyz or by polar coordinate r theta phi. Here this coordinate system, and a nucleus is assumed to be fixed at the origin of this coordinate system, and suppose this is the position of this electron at any instant of time within this hydrogen atom. So this position of this electron we can describe in terms of this xyz Cartesian coordinate or r theta phi polar coordinates, and this one is the x, this one is y, this one is z, and this position of this electron from this origin is called the radial distance. Radial distance is given by r, and this radial distance makes an angle with this z axis, and this is theta. And whenever we are making a projection from this P to P on the plane of xy, it cuts a Q, and OQ makes an angle with this x-axis phi. This is the azimuthal angle. This is azimuthal angle, this is zenith angle, this is the radial distance in polar coordinates. So whenever we shall describe the non-relativistic time-independent Schrödinger equation, this equation is del square psi plus 2 mu h cross square into E minus B psi equal to 0. This h cross is the reduced Planck's constant, and del square is the Laplacian operator. And this Laplacian operator in Cartesian coordinate is expressed as del 2 by del x square plus del 2 by del y square plus del 2 by del z square. In polar coordinate, it is given 1 by r square del by del r square del by del r plus 1 by r square sin theta del by del theta sin theta del by del theta plus 1 by r square sin square theta del 2 by del phi square. And the r is the, again I can call the r is the radial distance. This means the distance of this electron from this nucleus, and theta the zenith angle, and phi is the angular azimuthal angle. These are the three coordinates in the polar system. Mu is the reduced mass of this hydrogen atom, and the reduced mass expressed as mass of this nucleus into mass of this electron divided by mass of this nucleus plus mass of this electron. But this one is 1836 times greater than this one. So we can neglect this Me with respect to, in comparison to Mn, and this Mn will cancel. So this reduced mass is almost equal to mass of this electron. Though for the motion of this electron, we can also write Me instead of mu, but we shall continue to write mu instead of Me. This reduced mass measures the contribution of the particles, moving particles, in the process of the rotation. So here this mu is equal to Me, means only the electron is in motions and nucleus remains fixed, and it is placed in the origin of this coordinate system. This E the total energy of the system, and V the potential energy. And this potential energy originates from the Coulombic force of attraction of this electron by this nucleus. And this is sometimes also called central force field, as it is acted towards this center. The Coulombic force is equal to, here one unit positive, electronic charge positive, and one negative, and these two products, and divided by r square. So it is, the Coulombic force is minus E square by r square. So potential energy is derived from this Coulombic force like this way, minus integration infinity to r. At infinity, this potential energy equal to 0. When r equal to r, this potential energy is V. Means V is the potential energy at a distance r from this nucleus. Instead of Fc, we can write minus E square by r square. So whenever we are doing this integration and putting this limit, we have the expression of this potential energy equal to E square by r. And say this solutions of this Schrodinger equation gives this expression of this psi. Psi is very important wave functions for this electron in hydrogen atom, and it is what we call the atomic orbitals. And the atomic orbitals are the building blocks in the construction of this molecular orbital. And the molecular orbital again in turn helps us in understanding the chemical bonding, electronic structure, and the spectra of these molecules. Again, it is better, we can, from the simple mathematics I can also show the x equal to r sin theta cos phi, y equal to r sin theta sin phi, z equal to r cos theta. From the simple mathematics we can also have these relations from the Cartesian coordinates and the polar coordinates. Since the potential energy contains this one member of this polar coordinates, radial distance, so it is better to express this Schrödinger equation in terms of this polar coordinates, and it is easier to solve this Schrödinger equation whenever it is transformed into the polar coordinates. The Schrödinger equation, when converted into the polar coordinates, this del square, it is the del square written in polar coordinate, and psi plus this one also remains, and phi equal to 0. Here the psi, this one is the del square and psi, and this one remains the same. Instead of a v, we shall write minus e square by r, and again psi equal to 0. Psi is the wave function of this electron in hydrogen atom, and this plays a very important role for the construction of molecular orbitals. Not only that, every information for this system could be available from these expressions of this psi. Psi here is a function of r theta phi, and so psi r theta phi, they are independent coordinates, or I can say independent variables. So this psi could be expressed as a product of these three functions r, p, a. R is the radial function. It depends on this value of this r, and p depends on theta, and f depends on phi. These r, p, f, these three are the independent variables. And in short, I can write psi equal to r, p, a. Whenever this psi is replaced by RPF, we are having this one. Only psi is replaced by RPF. Here also psi is replaced by RPF. So whenever differentiating, since RPF are independent to each other, when it is differentiating with respect to this radial distance, this PF remains constant, and PF by r square del by del r, and this one remains the same, and here r is included. R is differentiated with respect to small r. In this case also, whenever differentiating with respect to theta, P only depends on theta, and Rf constant, and Rf here written here, r square sin theta, this one, and here del P by del theta. Plus again for this case, and f is a function of phi only. F is a function of phi only. Differentiating f with respect to phi, Rp constant, and here Rp taken out, and del to f by del phi square, plus this one remains the same, and here Pf equal to 0. So dividing by Rpf and multiplying by r square, this process, this operation is done in order to separate the Schrödinger equations into three coordinates, three equations, three independent equations, one depending on radial distance, another depending on this zenith angle, and the rest one depending on this azimuthal angle. So whenever we are dividing these equations by Rpf and multiplying by r square, this term only remains 1 by r, and this one, and here p, r square is gone, and Rpf also cancels, so p here, and this one, and here 1 by f sin square theta del to f by del phi square, and here r square is multiplied, and Rpf, we are dividing by Rpf, so Rpf will be absent here, equal to 0. So this can be written again 1 by r. Now d by dr, it is now becomes a single variable. This r only contains independent variable single equation. So d del is replaced by d by dr, r square dr by dr plus this term coming here and equal to, and this angular part taken right hand side minus, and this one and this one also coming here, and each side of these equations are independent. But if you change this theta and phi, then this part will change, keeping r fixed, then left hand side is fixed but right hand side is changing. Again, if we keep this theta phi fixed, r we shall change, then left hand side will change but right hand side remains fixed. This is possible mathematically only when each side of this equation is a constant, and this constant is L into L plus 1, and L is a number. You can see also this left hand side is dimensionless, right hand side also dimensionless, so this term also dimensionless. L is only the number, and this is called the azimuthal quantum number. So this Schrödinger equation now separated into two parts: the radial part d by dr r square, and this one, and this again here, and this L into L minus 1 coming here minus, and the r is multiplied, so r equal to 0. This is the radial part. This is the radial part of this Schrödinger equation. Similarly, the angular part is this one, this one, and del by del theta, and sine theta del p by del theta, plus this one again coming here, and minus this one coming plus L into L plus 1 equal to 0. This is the angular part which contains theta and phi, and this is the radial part which contains this r. Angular part of this Schrödinger equation again could be separated into two equations, one depending on theta and other depending on phi. For this purpose, let us multiply this angular part of this equation by sine square theta. Then sine theta p and d by d theta, sine theta dp by d theta, and this one L sine square theta is multiplied equal to minus 1 by f d2 f by d phi square, and this again by applying the same reason, these two are independent, and so each side is equal to some constant, and this is m square, and this constants m square or L minus L into L plus 1, these are written in order to solve these equations by using this polynomial algebra. So this now I can summarize these three equations separating this Schrödinger equation in polar coordinates. The r dependent equation is this one, already I have written earlier, and theta dependent equation is this one, and minus m square into p is multiplied equal to 0, and this last portion, this one equal to m square, so d2 f by d phi square plus m square f equal to 0. So these are the three independent equations, each depending on one independent coordinate, polar coordinates, and these equations could be solved by using the polynomial algebra. And whenever this equation 1 is solved, equation 1 contains this energy, total energy E, and this one is the potential energy. This separation, actually separation is possible only due to the fact that the potential energy depends only on r, radial distance, and this potential energy we call the spherically symmetrical potential energy. Means here is the nucleus at this point r, with the same radius we can consider a sphere, and each point on the surface of the sphere of a fixed radius will have the same potential energy. Now we can, by solving this equation, we can get this total energy, and total energy of this electron in hydrogen atom is minus 1 by n square mu e to the power 4 by 2 h cross square. If we replace this h cross by h, it is very more familiar. Minus 1 by n square 2 pi square mu e to the power 4 by h square. This equation, this expression of energy is the same as we have derived by very simple Bohr model of hydrogen atom, in which this electron is rotating around the nucleus, keeping this nucleus at the center. So this equation can also explain the hydrogen atom spectra. And another point, when n is increasing, this energy is also increasing as there is a negative sign. Not only this n determines this energy, n is called principal quantum number, and the value of n equal to 1, 2, 3, 4, 5, etc. excluding 0. If we put n equal to 0, then actually this En becomes minus infinity, which is not possible. Not only this principal quantum number determines this energy of this electron in hydrogen atom, but also it determines the distance of this electron from this nucleus. Are the value of n greater or the larger will be the distance of this electron from this nucleus. Say for state n equal to 2 is at larger distance from this nucleus than for the state n equal to 1. Again, I mention one important point. The energy is negative. Total energy is negative. Potential energy is also negative. Kinetic energy is always positive. So the total energy would be written sum of kinetic energy plus potential energy. This one is negative, this one is positive, but total energy negative. So potential energy magnitude is greater than the magnitude of this kinetic energy. It means that the kinetic motion of this electron is not for the kinetic energy of this electron will not remove, kinetic motion of this electron will not remove this electron from this influence of this nucleus. So this electron here is the bound electron, and for this why the electron, for this why the hydrogen atom is stable. And by solving this equation 2, we get for the equation 2 we get the two quantum numbers. One is L and another is M. L, the azimuthal quantum number, and L determines the angular momentum of this electron in hydrogen atom. And we all know the angular momentum is a very important property for this rotating system. So this eigenvalue equation, whenever P is found, we can, by solving this one, we can get this expression of this P function, and this P function, and this is the L cap, means operator of this angular momentum, and P equal to root over L into L plus 1 H cross and P. And so L equal to root over L into L plus 1 H cross. This is the magnitude of this angular momentum. Here lies a difference from this Bohr's concept. For the ground state of this hydrogen atom, this L equal to 0. L equal to 0. So this angular momentum equal to 0. But in Bohr's concept, the angular momentum for this ground state hydrogen is h cross nh by 2 pi means h cross. So here lies some difference between the quantum mechanical layer and the Bohr's model. So this L determines the magnitude of this angular momentum. The values of L equal to 0, 1, 2, 3 and n minus 1 means L depends on the value of A. When sometimes A actually determines the orbital, and when A equal to, it is sometimes written in terms of these letters. So A equal to 0, it is written S orbital. A equal to 1, P orbital. P orbitals. P orbitals. And A equal to 2, D orbitals. And A equal to 3, and it is the F orbitals. So for the value of A, the orbitals, and last one, solving the equation 3, we can get an expression of this F. We have already solved this type of equations as this Lz cap equal to minus h cross dy d phi. This is the operator of this z component of angular momentum, and here is the f is obtained from here, or it is the function, and this one equal to Lz f. This is the magnitude, and this eigenvalue equation when solved, we shall get this value of expression of f equal to 1 by root over 2 pi into I m phi, and Lz equal to mh cross, m having the value equal to 0, 1, plus minus 1, plus minus 2, plus minus 3, etc. The value of m depends on this value of L, and minus L minus 1, minus L minus 2, and minus 2, minus 1, 0, plus 1, plus 2, plus L minus 2, plus L minus 1, plus L, etc. Total value of m for a given value of L equal to twice L plus 1. When for L equal to 2, m equal to 0. This m again measures the degeneracy of these orbitals. L equal to 0 means s orbital, and s orbital, m equal to 0, only one value, so this s orbital is non-degenerate. L equal to 1, m equal to minus 1, 0, plus 1, three values are there. For a given total value of m for a given value of L equal to 2L plus 1. When L equal to 1, m equal to total value 3 means these p orbitals are threefold degenerate. And when L equal to 2, this m will have this total 5 values. So this d orbital is fivefold degenerate. And in case of L equal to 3, it is total value of m equal to 7 means f orbital is sevenfold degenerate. So the degeneracy of these orbitals could be obtained from this magnitude of this m, or the total magnitude of this m. So the wave function for the electron in hydrogen atom is expressed as psi n m r theta phi, and product of three functions. F depends on r depends on radial distance, and r is defined by the quantum number n and l. P defined by l and m, and this depends on theta, and F depends on phi and defined by the magnetic quantum number m. So this normalization, whenever this wave function is normalized, this expression is given, and d term here the small element of volume r square dr sin theta d theta d phi. So the all space means r 0 to integration, r 0 to infinity, theta 0 to pi and phi 0 to 2 pi, and this value, and instead of d tau we write here this is equal to 1. By using this one we can get this normalized wave function which we call the atomic orbitals. The probability density of this probability density of finding means it is the probability of finding this electron at a given point defined by r theta phi. That means at this point this value is wave function and it is the complex conjugate of this wave function, and product of the two will give you the probability density. And whenever this one is multiplied by d tau, it gives the probability of finding this electron in a small element of volume located at the point P, and this point is r theta phi. And whenever these wave functions we are given, this is psi 2100 and this value, and psi 200 this value, psi 211 bar, this is psi 2 px, and this is here the x means it is oriented along this x-axis, and this value is y oriented along this y directions, and this one along this z directions, and r sin theta cos phi equal to x, and r sin theta sin phi y, and r cos theta equal to z. So this is all about this today's lecture. In my next class we shall elaborately discuss all these atomic orbitals. In the lecture, in part 2 we shall discuss this 1s orbital, and part 3 2s orbitals, and part 4 we shall discuss this p orbitals. Thanks you all who are watching this video.